All right, we have another related rate problem. Now, when you see a problem like this, you read it through. How do you know that it is a related rate problem? Well, sometimes you have to read to the very last sentence where it says, how must the rate of production change to meet this goal? So we're looking for a rate, how something is changing. That tells us we have a related rate problem. So the first step with a related rate problem is always to identify what we know. And so what we know is, first of all, monthly production, which is the variable X, is 3,800. So I'm going to write down X equals 3,800. We also know that we want the average cost per unit to decrease by 1984. So there is a rate. That's the rate that we're given. So the change in average cost with respect to time is going to be a negative 19.84. And of course, we already identified over here, how must the rate of production be changing? So we want to find dx dt. That is what we are finding. So again, we have to be given a fixed number, given a rate, and identify what we're looking for. So we're dealing with average cost. We're given the cost function. And we should know by now, I've done this in quite a few other videos, that to determine the average cost, we simply divide the cost function by X. And so we will end up with the average cost function being equal to 176x to the negative 1 plus 17 plus 0.1x. Now let's find the derivative of this function implicitly. So the derivative of c bar x is 1 times c bar of x with respect to time. And this would be negative 176 x to the negative 2 or over x squared. Derivative of 17 becomes 0 and 0.1 times dx dt plus 0.1 times dx dt. So we want to solve this for dx dt, which we have in two places. No problem. We're going to just factor out the dx dt. And what we would have is negative 176 over x squared plus 0.1. And then solve that for dx dt. I'll put that over on the left. That would be equal to dc bar of x dt, all divided by negative 176 over x squared plus 0.1. Now we know what the numerator is. That has to be a negative 19.84. That was the rate that we were given. And then we're dividing this by a negative 176 over 3,800. That was my value of x squared plus 0.1. Plugging that into your calculator in Desmos, we would get dx dt is equal to negative 198.42. So that is what we're looking for. In other words, the rate of production needs to decrease by 198.42. And again, you would have to see in more whether the answer is rounded to the nearest integer, which would be 198, decreasing by 198 units per month to answer this question.